Hello everyone, welcome back to our channel Alchemist. Today we are going to see the continuation part of organic chemistry. Let's get into the video. In the previous lectures, we saw the classification of hydrocarbons and let's revise the classification and continue with this. As we all know, there are two types of hydrocarbon, namely open chain or it is otherwise known as aliphatic, and then cyclic or aromatic. And then open chain is further divided into two types, that is saturated and unsaturated. And then saturated is again further divided into alkanes and unsaturated is again further divided into alkenes and alkynes. Okay, these are the basic classification. Okay, let's see alkanes in detail. Okay, the general formula of alkanes is CnH2n plus 2. Okay, this is the general formula of alkane. These are the examples and let's see how it applies with this formula. Okay, the first one, if we put n is equal to 1, okay, put n is equal to 1 in the general formula, that is C1H21 in plus 2. So the formed structure is CH4. Okay, this is the structure of CH4, that is methane. And when we put n is equal to 2, substitute in the general formula, we get C2H6. Okay, that is ethane molecule. And then the third one, put n is equal to 3 in the general formula, we put 3 in the n place. Okay, so C3H2 3 plus 2 is equal to C3H8. Okay, this is the structure of C3H8, that is propane. And then the fourth one is n is equal to 4, substitute 4 in the n place, so C4H2 4 plus 2, that is C4H10. This is the structure of C4H10 butane. And then n is equal to 5, put 5 in the n place, we get C5H12, that is pentane. This is the structure of pentane. Okay, these are the alkanes classification. Reminder is the general formula, and these are the alkanes. And as we all know, if it is one carbon, the root word is meth. If two carbons, it's eth, and three carbon it's prop, and four carbon it's but, and five carbon it's pen. It's an alkane, so it ends with ane. Okay, these are the classification of alkanes. Okay, in the previous slide we saw alkanes, and in this slide we are going to see the alkenes in detail. The general formula of alkenes is CnH2n, and when we put n is equal to 1, okay, n is equal to 1 doesn't exist in alkene because as we all know, carbon has 4 covalent bonds. Okay, in this when we substitute 1 in CnH2n, it gives only CH2. Okay, only 2 hydrogen is present, and the tetravalency of carbon doesn't shoots for this compound. So n is equal to 1 doesn't exist. Okay, and then n is equal to 2, put 2 in the n place, so CnH2n is equal to C2H2 into 2, so C2H4. This is the first structural formula or first molecular formula for alkenes. Okay, it is named as ethene, and this is the structure of ethene. And then n is equal to 3. When we put n is equal to 3 in the n place, we get C3H6, that is propene. This is the structure of propene. And then n is equal to 4, C4H2 into 4, so C4H8. It is butene. This is the structure of butene. Okay, and then the fifth one, n is equal to 5. We put n 5 in the nth place, so C5H2 into 5. So C5H10, it is pentene. This is the structure of pentene. And then n is equal to 6. Put 6 in the nth place. We get C6H12, that is hexene. This is the structure of hexene. Okay, as we all know, this is the root word: eth, prop, bute, pent, hex. Okay, as we all know, this is the alkene, so it ends with ethene, ene, and then propene and butene, pentene, hexene. Okay, as we all know, carbon, if the carbon number is 2, it's eth, and carbon number 3, it's prop, and carbon number 4, it's bute, and carbon number 5, it's pent, and carbon number 6 is hex, and so on up to 10 means dec, etc. Okay. And then we are going to see the alkynes in detail. In the previous slides, we saw alkane and alkene. The general molecular formula for alkane is CnH2n plus 2, and for alkene CnH2n. In this, the general molecular formula is CnH2n minus 2 is the general formula. If we put n is equal to 1, it also didn't exit. Okay, when we put 1 in the nth place, it gives only C and H0. Okay, as we all know, carbon forms 4 covalent bonds with hydrogen. In this, there are no hydrogen present, so it doesn't exit. And then if we put n is equal to 2 in the nth place, it gives C2H2, that is ethyne. This is the structure of ethyne. And then if we put n is equal to 3, it gives C3H4, propine. Okay, this is the structure of propine. And n is equal to 4, it is C4H6, that is butane. This is the structure of butane. And n is equal to 5, it's pentine. This is the structure of pentine. And n is equal to 6, C6H10, that is hexane. This is the structure of hexane. Okay. As we all know, for 2 carbons, eth, and 3 prop, and 4 bute, and 5 pent, and 6 hex. Okay, as it comes under alkynes, it ends with yne, yne. Okay, ethyne, propyne, butane, pentyne, and hexane. That's all about alkynes. In this slide, we are going to see the alkyl groups in detail. The general formula for alkyl groups is CnH2n plus 1. This is the general formula for alkyl groups. Let's take an example of alkane, and in this we take the example as methane. Okay, that is CH4. This is methane. When we remove one hydrogen from methane, it becomes an alkyl. That is, it is methyl. That is, the fourth place is vacant and this group becomes an alkyl group. Okay. The examples are, these are the examples: methane, ethane, propane, butane, and pentane. From all these, we remove one hydrogen. It becomes alkyl. That is methyl, ethyl, propyl, butyl, and pentyl. These are the examples for alkyl groups. In this slide, we are going to see the functional group. The first functional group we are going to see is the alkanes. Alkanes means methane, ethane, up to decane, etc. And all the alkanes are consist of single bonds. Okay. And then alkenes. Alkenes means double bonds. That is ethene, propane, butene, etc. And then alkyne, that is triple bond, that is ethyne, propyne, butane, etc. Arenes. Arenes means benzene, that cyclic compounds are known as arenes. These are the example for functional group of alkene, that is, they consist of 2 carbon. So it's ethane, it's ethene, it's ethyne. Okay, when we put C carbon in the R, it becomes ethyne or acetylene. Okay, arene, the example for arene is benzene. Let's see the functional groups in detail. The first one is alcohol, that is OH group. See this ROH ends with OH and it's an alcohol group. The examples are methanol, ethanol, etc. The molecular formula is CH3OH. Okay. If it ethane, that is two carbons present, it is ethanol. Okay. And then carboxylic group, that is COOH group. See this RCOOH means carboxyl group. The example is propanoic acid, butanoic acid, pentanoic acid, etc. Propane means 3 carbon present. If it is 4 carbon, it is butanoic, and if it 5 carbon present, it is pentanoic, etc. Okay. And then the aldehyde group. Aldehyde group means CHO group. See this RCHO aldehyde group. The example is CH3CHO. It's ethanol, propanol, pentanal, etc. Ethanol means 2 carbon is present and an aldehyde group is present, so ethanol. And then if 3 carbon is present, it's propanol, 4 carbon is butanol, 5 carbon is pentanol, etc. And then ketone group. Ketone group means CO group is present. See this 2 alkyl and CO group is present, so ketone group. The example is butanone, pentanone, hexanone, etc. Butanone means 4 carbon is present. It's butanone. If it's 5 carbon, it's pentanone. If it's 6 carbon, it's hexanone, etc. Let's see other functional groups too. As already we saw alkane, alkene, alkyne are the functional groups, and this is the new one, that is alkyl halide. As already we see the alkyl groups, that is removal of one hydrogen from alkane gives alkyl. Okay. From that we add the halides, that is bromine, chlorine, iodine, etc. It forms alkyl halides. Okay. And alcohol, as already we saw, thiol. Thiol means SH group is present. Ether means O is present. Amine means NH2. Ketone, as already we saw, C double bond O. Aldehyde means CHO. Carboxylic acid means COOH. Carboxylic ester means COOCH3. And then carboxylic amide means NH. And then nitrile means C triple bond N. Okay, these are the other functional groups. If you have any doubts, put it in the comment box. We will surely help you out. And thank you for watching.